Imagine a place where life itself has withered. A land so devoid of moisture, so scorched by the sun, that hope itself seems a mirage. We've been told for millennia that deserts are dead zones, vast, insurmountable barriers to life. But what if everything we thought we knew about these desolate landscapes was wrong? What if, in the heart of this impossible barrenness, a secret could unlock an endless spring? They took a gamble, a revolutionary material born from the most advanced labs, and planted it directly into the unforgiving silence of a dead desert. The world watched skeptical. Nature, they said, cannot be defied. But then, the impossible happened. This isn't just a story of scientific discovery. This is a tale of defiance, a testament to human ingenuity, and a shocking revelation that will forever change how we perceive our planet's most precious resource. Consider the canvas, a desert so utterly devoid of life, its air so bone-dry, it registers as low as 30% relative humidity. For context, comfortable indoor humidity is typically between 40 to 60%. Here, rain isn't just rare, it's a forgotten legend. And in this brutal environment, a team of visionary researchers from the Massachusetts Institute of Technology dared to challenge the fundamental rules of nature. They introduced a substance unlike any other, a revolutionary hydrogel. This isn't just a polymer. It's an intricately engineered network infused with highly specialized salts. While traditional methods of water harvesting, like massive desalination plants, demand immense energy, with some consuming up to 10 kilowatt-hours per cubic meter of water produced, this gel works with elegant, passive efficiency. Think of it as a silent, invisible vacuum cleaner for moisture. It doesn't require complex infrastructure, massive power grids, or a pipeline to the ocean. It simply sits there, absorbing the unseen water vapor from the very air around it. This is why it's so revolutionary. It taps into an atmospheric reservoir that holds an estimated 13 trillion tons of water at any given moment, a resource virtually limitless, even in the driest regions. The proof arrived under the searing desert sun. In real-world tests, a single surprisingly small disk of this miraculous gel, designed to be easily deployed, began to produce. It collected gallons of clean, potable water. This isn't an exaggerated claim. This is quantifiable scientific data from rigorous field trials. This means that a compact, backpack-sized device, holding just a few of these disks, could potentially provide a family with their entire daily water needs, fundamentally transforming survival in places where life has always been a struggle against thirst. How does this seemingly impossible act occur? The secret lies in a masterful blend of material science and chemical engineering. At its heart, this is a salt-infused polymer network, specifically a polyacrylamide hydrogel imbued with highly hygroscopic salts like lithium chloride, LiCl. Lithium chloride is a powerful desiccant. It's infamous for its ability to pull moisture from the air, but in this application, it's meticulously controlled within the gel matrix. While it can absorb over 10 times its own weight in moisture at 75% relative humidity, its true genius here is its effectiveness even at extremely low humidity levels. The hydrogel acts as a stable, porous scaffold, ensuring the salt is evenly distributed and can efficiently interact with water vapor. The process is brilliantly cyclical, requiring no external power input beyond ambient sunlight. As temperatures drop at night, even slightly, and relative humidity often experiences a marginal increase, the gel becomes a powerful water magnet. The carefully designed, interconnected pore structure of the hydrogel, avoiding tiny nanoscale pores that could hinder release, allows rapid diffusion of water vapor. The lithium chloride then leverages potent hydrogen bonding and van der Waals forces to capture these water molecules. Studies show that under conditions mirroring very dry deserts, at just 30% relative humidity, these gels can absorb an astonishing 1.5 to 1.79 grams of water for every single gram of material over a 24-hour cycle. When the sun rises and solar radiation heats the gel, a precise thermoresponsive mechanism kicks in. As the gel's temperature increases, the chemical affinity between the water molecules and the polymer salt network dramatically weakens. The absorbed water is then actively desorbed and condensed into pure liquid form. A critical innovation is the addition of glycerol to the hydrogel. This minimizes salt leakage, ensuring the collected water is remarkably pure. Rigorous testing has confirmed that salt levels in the collected water are consistently below 100 milligrams per liter, well within the World Health Organization's guideline of 250 milligrams per liter for safe drinking water. This means the water isn't just collected, it's purified by the process itself. This entire system operates silently, sustainably, and with an energy efficiency that dwarfs conventional methods. It requires no pumps, no electricity, no complex infrastructure, just the fundamental forces of materials science interacting with the environment. This elegant simplicity is what makes it so revolutionary. This gel isn't just a fascinating experiment. It's a direct answer to one of humanity's most pressing and rapidly escalating crises. The statistics are horrifying. 2.2 billion people currently lack access to safely managed drinking water. That's nearly a quarter of the global population. A staggering 2.7 billion people, more than a third of humanity, endure severe water scarcity for at least 1 month every single year. And the situation is worsening. By 2050, the number of people living in severely water-scarce areas is projected to increase to between 2.7 and 3.2 billion, up from 1.9 billion in the early 2010s. This isn't a distant future, it's accelerating. Our global freshwater resources are under immense strain. Agriculture alone consumes approximately 70% of the world's accessible freshwater, with a significant portion of that often lost to inefficient irrigation. This gel could radically alter the agricultural landscape, enabling food production in regions previously thought impossible. The human toll is catastrophic. Over 1 million people die each year from preventable diseases linked to unsafe water and sanitation. Every single day, nearly 1,400 children under the age of 5 die from diarrheal diseases caused by contaminated water, meaning a child dies tragically every 2 minutes. This technology directly addresses this silent epidemic by providing an accessible source of pure water. The MIT team isn't resting. Their vision extends far beyond a single disk in the desert. They are actively exploring scalable solutions that could fundamentally reshape our world. Picture emergency relief efforts in disaster zones. This gel could be deployed in compact, rapid response kits, providing immediate access to safe drinking water where infrastructure has been obliterated. And for everyday life, the implications are profound. One day, your backpack could contain a personal atmospheric water generator. No wires, no heavy batteries, no complex plumbing. Just the sun, the air, and the silent, astonishing power of this material. Campers, survivalists, remote communities, everyone could have access to their own perpetual water source. And if you were as shocked and hopeful by this extraordinary story as we were, make sure to like this video, share it widely with your friends, and subscribe for more world-changing revelations about our planet's future.